This lesson is an introduction to logarithmic functions. So when we think about exponential, we think about exponents. So if I were to ask you, how many times do we have to multiply 2 to get itself, by itself, to get to 8? Well, we would think 2 times 2 is 4 times 2 will give me 8. So I could write that exponentially as 2 to the third power gives me 8. My base is 2, raised to the power of 3 gives me 8. If I wanted to get to 16, think about how many times I'd have to write it. So I'd have 2 times 2 times 2, I know that gets 8, and one more would get me 16. Okay, I could write that 2 to the third. However, if I ask you to find out 384, I don't know that I'd want to spend the time writing all that out. So to solve problems, we use an easier method, and that method is with logarithms. So we are going to learn about logarithms and how they relate to exponents. We often just call them logs for abbreviation. Okay? So if you look here, we have the parent function of an equation or an exponential with an exponent, and I have an a equals b to the x. So for an example, I may say 8 is equal to 2x, or I could write it as b to the x is a. 2x equals 8. And we could think to ourselves, what would work? 2 to the what power would give me 8. We've already done that one, so we know it's 3, so we can actually solve that. Now, to help us solve more complex things, we have to know how to convert between the two types of functions here. So we have exponential and we have logarithms. Now, the logarithm is laid out like log base b to the a equals x. So log of b to the a, or log BA equals x. So the b is our base. Notice that it's the same thing in our b over here. Okay, b's are bases. That's kind of what's holding everything up. So you can think about the b as being the base. It's holding it up. It's the power, or the base of the power. And then a is our argument. Okay, a is our argument. So like our answer. Okay, our solution sometimes, or what it equals. And then x is our power. Okay, so the way that we would write something, example like this, maybe log base 2, notice it's a little subscript, drop down, log base 2 of 32 equals what? X. Okay, so that's how it's written. So we have to know how to convert those things. These are inverses of each other. And that's very important for you to know. So we've already learned about what inverse means. The x and y's change is to undo each other. So these are inverses of each other. Put a little bubble around that. That's important. So let's look at this log base 2 of 32 equals x. If we wanted to get it back in the form of the exponential, we could say, what is the base? Our base is 2. 2 raised to what? That's our power, equals 32. Okay? And then we could use our knowledge of exponents and square roots and cube roots and all the good fun stuff, multiplication tables, to help us find that. All right, let's go a little bit more in depth here. So we have general form of exponentials and logarithms. So general form, we would have b to the x. That's kind of what we talked about up above. Or you may see this, and this is a higher level. You'll see this in calculus, e to the x. E is not a variable. It is actually a number. It is a natural log, okay? And it actually has a value. So we'll talk about it briefly, but we're really not going to practice much with that since it's higher level. Now, these types of graphs we've talked about previously, they are either growing or decaying. So we can have, this is a growth here. They have a horizontal asymptote, and we've worked a lot with those. So that's just kind of how they look. Now logarithms look, their general form is log of x. This could also be written as log base 10 of x. So if you do not see a base beside a log, a little subscript, then we know, or we assume that, or it's presumed, not assumed, but presumed that it's a base 10. That is called a common log. And I made a little note down here. You may want to add that. A common log. And it's a log written without a base, and it's presumed to have the base of 10. Okay? Our calculators will actually solve those pretty easy for us once we learn, but it's not so easy to put in different ones into the handheld calculators. So these type would look something like this, parent function wise. We would have something like that. So notice there is an inverse. Let's do a little line there. We know that we always reflect across the line y equals x. So you can think about when, if we were to graph an exponential and its inverse would be the log function, they would be reflecting across that y equals x. So it's the same reflected line. So the next section, we're going to learn how to rewrite or convert each exponential equation into a logarithmic equation. So a helpful hint when rewriting and converting, up here in our box here, a base is always the base. So if we have a base in exponential, it's going to be the base in logarithms and vice versa. And the other helpful hint is exponents never touches the log. The logs never touch the exponent. That means they're on opposite sides. So you'll see more with our examples. So here in number 1, we have 10 raised to the third power equals 1,000. Great. Let's write it as a log. So we start as log, find our base. Our base is 10. Log 10, we do not have the logs on the same side as the power, so we can't put that next. So it's log of what? 1,000 equals our exponent. Okay, now because this is a base 10, a common log, we could also write this as log 1,000 equals 3. Okay, those are exactly the same thing. All right, let's look at number 2. So log, because we're going to log, so we start with log, base, a little subscript, of 125 equals our power of 3. All right, I want you to try 3 and 4 and see how you do. So for number 3, well, you would have gotten log base 4 of 25 hundredths, or 0.25, equals a negative 1. So pay attention that when your argument, which is where our A would be, when it is less than 1 but greater than 0, you will get a negative answer on the other side. So for number 4, you have log base 3 of 1/27. That is, of course, less than 1, greater than 0, it equals negative 3. All right, now we're going to move on to converting from logs to exponential. So with this one, we're looking for the base. Base is always the base in either form. The logs and the exponents can't touch the same side, so we know we're saying this base raised to this power gives us this answer. So we have here. Then we have 8 base raised to what? 1/3 gives us 2. So notice with this one we have the base of 6 raised to the 0. We always know anything raised to the 0 power is 1. And then with the last one, 5 raised to the 2 equals 25. So these are much easier to see the connections to. In this section, we're going to look at how to evaluate logarithmic functions without a calculator. So we're thinking the log base 7 of 1/343. what we're really asking is what power of what or will get us our answer. What power of blank will get blank? Okay, so you can think about this. Base 7 raised to what gets me 1 over 343. So when we think about what has to happen to become a fraction, a whole number to become a fraction, we know that the exponent needs to be negative. So we can then think about what 7 times what would give us 343. And then a raised to what power? How many times itself? So 7 times 7 times 7 times 7, how many ever times? So if you know your powers and you know how to do quick multiplication, you could say, well, I know it's a negative, and I know 7 times 7 is 49. 49 times 7 is 343. So that means that x, the power, has to be negative 3. All right, let's do another one with a fraction. So we're looking for the base of 2 raised to what, power of what, will get me 1/8. Okay, so what power will get me to 1/8? So I know again that to be a fraction as my answer, I have to use a negative value. So we already talked about how many times we have to multiply to get to 8. 2 times 2 is 4. 4 times 2 is 8. So I know it's going to be 3, and it has to be a negative 3 to actually work there. Okay, I want you to try the next 4, and then come back and see how you do. All right, so for number 3, you should have gotten 2, and then 4 is 3, and then 5 and 6 are both 2. So check and see how you did with that. All right, we're going to move to number 7 through 10 here. So notice we have some fractions here, and we're going to do the same process. So we're asking ourselves 7 to what power gets me 1 over 49. To be able to become a fraction, I know that it's got to be a negative number. So then I think to myself, well, 7 times raised to what power? 7 times itself, how many times can get me 49? Well, I know that's 2, so it would have to be a negative 2. Now, number 8 is a little bit tough because we're not seeing exactly a whole number here per se. So I'm saying 64 raised to what power equals 1/4. So I've got to think here, to get it to be a fraction in the answer, I need a negative number. So I already know that much. But if I think about something to get to 4, I'm getting smaller than what I'm given. So I've got to think about square roots, cube roots, things like that. So if I think about it's got to be a negative, I'm looking for what fraction, what number to make it smaller. I know this is going to be a fraction, so I'm going to have a fraction answer. Well, if I do something like 64 to the negative half, I think about that's the same thing as writing it as 1 over 64 to the half. And I'm raising it to the half, which means I'm taking the square root of it. Well, if I try to do the square root, and you can use your calculator to see this, and I do the square root of 64, I'm going to end up with 8. Okay, well, I'm trying to get to 4. So maybe let's try 3. I'll put 3 here. So when I'm doing 1 over 64 raised to the third, I'm actually taking the cube root. Okay, the cube root of 64. So that's what that 3 tells me. I'm doing that cube root over 1. Well, that will give me 4. So now I know that I would get 4. And I use a negative 1/3. So my answer is negative 1/3. All right, your final two answers would be 2 and negative 3. So make sure you understand how that came to be. And then it's time to practice.